get carried away with the problem, I'll just keep on going, all of a sudden it's 8 o'clock. So let me know.
Okay.
Say, Professor, it's time to stop. Okay, now, since I do need to stop. Guys, I'm gonna go ahead and do this. We're gonna be responsible for, I'm talking about functions. So we're gonna be responsible for what they call parent graphs or essentials. In fact, is elementary. Certain, what they call elementary functions and what their shape looks like. I see a parabola on here, I see a straight line. So we're gonna be responsible for it. When I see something like that, I'll recognize its shape. So I thought I'd give you a handout here with the, what they call the library of functions, elementary functions. On this, you can do me a favor and pass that. Guys, that's just a resource for you, so you'll know, they say x squared, what its shape looks like, x cubed, and so forth and so on. Now, I am, by limited time here, I want to take a look at just a couple of these that you may not recognize. Everyone recognizes this as parabola. But some that you may not say, Professor, really, I didn't know that shape looked like that before. Now, I think on that handout they mentioned, just a few here. If you're given the function is this function, I'm going to start with x cubed, not x squared. I know what x squared is, we all do. Guys, x cubed, some students may say, Professor, I see it on the handout, and I sort of knew before I walked in here what x cubed looks like as a graph, and it is a function, and I think the handout shows, you can always plot points to make sure it looks good. We're not going to take the time to plot points, even though you could. But I think many students recognize what f of x equals x cubed as a graph looks like. And I think, as we remind me before I do it, does it go up like this? Does it go through 0? And on up like that, something like this? Yes or no? For a basic shape. And I'll accept that. Now, so later on, maybe tomorrow. What is tomorrow, Thursday? Oh, yeah. Maybe tomorrow they'll say, okay, now take this basic shape, this is for x cubed. And you know what they're going to ask you to do with it? They're going to ask you to shift it up, shift it down, or horizontally shift it to the left, horizontally shift it to the right, stretch it. But keep that parent graph, but do that to that parent graph and start doing those so-called transformations on it. But right now, guys, all I want to look at is it. Now the domain. Based on the graph. I was looking for domain before the break. I was just looking at the graph. What do you think the extent of the x's, and this is the x-axis here, what do you think the extent of the x-axis is for this graph? From left to right. Does it cover the entire x-axis? So negative infinity, or positive infinity, or all real numbers. The range, of course, is a set of y's, and I know what the y is. This is the y-axis. And the way it's going, what, up and down? Definitely, if it drops down forever, goes up forever. The range covers everything. So there's the domain, the range of one of those on your handout. And then we'll see that probably come up later on in some other problem. Part B, we may not at this point recognize this one. Who knows, we might, some students may. A square root. So if I see a square root, I've seen square roots in this class, working square roots. So what does a basic square root graph look like? You can plot points, you can do it. The handout says, if I'm thinking correctly here, it should be, I'm going to describe it as a sideways parabola. And see if you guys will agree with it. Does it look something like that on your handout? And that's a graph. That's what a square root graph looks like. You know what the class we do tomorrow, more than likely? Yep, take it and shift it, stretch it, move it, use a transformation on it. So that's the parent graph right there. Domain on this one, guys, is domain. Be careful from left to right. This is the x-axis. It must be written as bracket, starts with 0, and goes to infinity for the domain. Range, which is a set of y's. And the way this graph looks on that grid looks like what? It drops down to a low of what? 0. And the implication is how high up is it going? Infinity. This bracket, look at this, same as the domain was in this case. So there's my domain range on that basic square root graph. Now I know what a square root graph in my mind now looks like if I see square root. Letter C, we may have forgotten this one. I think it's on there. The absolute value of x. What does the absolute value of x look like? And your handout says, and we'll see the domain and the range and take a look at this. I think it looks a lot like a V-shaped graph. And I'm correct here. Does it look something like this? For the absolute value of x graph. Does that look something like what your handout shows? Look at this. Is that true, guys? Okay. So we've got the basic absolute value graph, the basic x cubed graph, the basic, I call them parent graphs, square root x graph, and I think there were a few more on there, right? So set me up for tomorrow. Again, this will be the tough part coming up tomorrow. When they ask me now, and I'm going to ask you right now from what I see up here, suppose tomorrow, let's take this function here. They give me, let's call it h of x. And they give me, and I need some responses here. They give me that to graph. This is going to just sort of lead you into where we're going tomorrow. That's going to be a little input. We know what the graph looks like. Here's the graph. That's the parent. Now, they're saying now, look at that, you should know from what it looks like they're written, what to do to that parent graph to get the graph you're looking for. Now, can anyone give me an idea of what, the way it looks, absolute value x subtract 4, then I think I threw it plus 6. Something like that. Do. Nikki, starts out.
I think it's going to go to the right 4.
Thank you. She says, Professor, there's going to be a horizontal, we'll call it horizontal, shift. Nikki said, Professor, I think it's going to go to the right. Nikki, how many units do you think it's going to go? To the right. 4 units. She's exactly right. Now, I haven't discussed this yet. We're going to hand you out for that also tomorrow. She said, Professor, I think I remember it's going to shift 4 to the right. What's going to shift? This red graph. And then I see a +6, I'm not finished though with it. After it shifts 4 to the right, anyone tell me what that +6 may mean? There we go. Up 6. And they call that a vertical shift. A little detail here. And it was up 6. So after I do those two transformations, they call it, two transformations on that red parent graph, I have the graph that we're looking for. This one has a horizontal shift and a vertical shift. We're done. Before I leave it, anyone tell me on this one? Suppose, just out of curiosity, I have h of x, and I want you to do this on this red graph. Let's throw a negative sign in front of the square root. Can anyone tell me, even though I have not done this with you guys yet, just trying to get some discussion, what do you think that will do to that red graph? John?
Flex it around the x-axis.
It's going to do what? It's going to do this, I'm hearing, reflect over the x-axis like that. The negative sign there will indicate that it's going to just flip over the x-axis. Guys, back, we have the names for all those. I have not done this yet, but I thought I would do just a little with you today. Okay, so at least you got the parent graph, and we'll be start doing transformations with it. On front of you. Suppose I even did this. Just out of curiosity. Jonathan's already told me what the negative sign does. It does that. It just flips it, reflects it across the x-axis. What do you think if I threw a 2 in there also? Any idea what the 2 does? Yes?
Stretch it vertically by.
Thank you. Vertical stretch by a factor of 2. It's going to also stretch the graph. Okay, and reflect it across the x-axis. I have 2 transformations going on. Guys, that sort of sets me up for tomorrow, but for my time, the little time I have left, part 2, all I need, all this done this summer, I have, except a note here. Oh yes, here goes. I'm gonna draw a graph. Get some input from you guys. I'm gonna set you up for tomorrow. Suppose I have a graph that looks like this. Now, we're entering at this point calculus. I go to the grid, and all of a sudden, I've taught calculus many times, you see a graph that does something like this. And all you make it do this. And I on the side there will recognize this as a function. I didn't give a name to it. So on the side say this does represent a function. I will call it y is equal to f of x. First, can I, sure enough, classify that as representing a function? It passes the what? Vertical line test. Now, I'm not going to give you the name, but you see when I start giving the name to it. Just look at today just as a shape, but I know it's a function. Domain, that's easily seen. From left to right along the x-axis, guys, I think it's another everything. Works. Range, yes, the way I make this drop down forever, go up forever. That range is negative infinity through positive infinity. I know at least the domain and the range. Are there some x-intercepts? Does my red graph cross the x-axis at certain points?
Yes.
Looks like I didn't label them for you. Got one here, one here, one here. There are 3 x-intercepts. Is there a y-intercept? Any at all?
Yes.
Yeah, intersects the y-axis here. I'll be asking to find all that for me pretty soon. Now, since you're going to be entering calculus, most of us. Whew, one of my students asked me at the break about grad school. Oh my goodness, right today, this graph here. Wait till you get to grad school. Because you get to focus on what you want to focus on. Undergrad, you're going to take maybe a history class that may require a foreign language class of some sort. They may require this, they may require that, And then, yes, you get to take some courses that you were there for to begin with, like me, for math. That was undergrad. So to get your degree, you do what they say to do. You don't argue with them. Yes, if they say, well, professor, you need a foreign language class. I took it. I took 2 classes. When I got to grad school, oh, it was different. What's your major, professor? Math. I had math all day. I had a math class at 8 o'clock in the morning. Noon, I had another math class. And 3 p.m. in the afternoon, another math class. Oh, I had a smile on my face. Did it work me? Oh, it worked me. I had all that done. That's what grad school was. I got to focus on what I wanted to focus on. Math, math, math. That's all it is. They're not going to tell me to take an English class. I didn't have to know, not in grad school. They're going to set you up for what you are interested in. My interest was math. So my interest was math. I did it all. Then you say, well, professor, what, after all this, what do you have to do? Well, then you get to write something called a dissertation. What? You spend a couple of years there at grad school, you take all these classes, and you love your math classes, you're doing pretty well in your math classes, and good grades and all that. It's just like undergrad, and you graduate, and they give you your degree. No. They ask you to write what they call a dissertation, a thesis, a paper. They want a book. And they usually give you a semester off. That's all you need to focus on is, mine was math. They said, come on, Ramsey, go out there and research. Research what? Research math. Oh boy, I can do math. I've never researched math. So thank goodness they gave me an advisor, and that's what's going to happen when you get finally to grad school. We're going to show at the very end, before they grant that degree to you, you got to find some topic that they want you to do some research on, and pretty soon I found a topic in math, and it's got to be volumes of papers, and they want you to publish that. And then I thought I was finished. They said, no, Ramsey, you're not quite finished yet. I said, what do I do? Now, we're going to have 3 professors to come into a classroom with you shortly, and they're going to read your dissertation through, and it's a thick dissertation. They're going to read everything you said, and they're going to have questions for you. And if one of those 3 professors finds something that they don't like, you'd stay another semester. Oh, okay. So was I nervous? I was nervous. That's when you finally get nervous. You're ready to leave the university. You've already done all your work. You're ready to leave. No, Rich, you're not going to leave yet. 3 o'clock in the afternoon on a hot August day, I'll never forget. No air conditioning in that room. Open the door, walked in, 3 professors sitting there. They introduced themselves. I introduced myself. And they'd already read the dissertation, the thesis. Ramsey on page 200 made a reference to a mathematician. Yeah, I did. I made a reference to some famous mathematician in my work. Did you do, okay, I'm missing his name. Did I know the man? No, I didn't know the man. I didn't know Pythagoras. Pythagorean theorem. I didn't know Pythagoras. I may have used his name in my thesis. Did I know the man? I didn't know the man. They said, can you tell us something about him? I don't know him. I just said, I was using Pythagorean theorem on this problem. Have you guys heard of Pythagoras? Pythagorean theorem? Have you met him? No. I never met the man. So I thought, ooh, I'm not going to pass. So I get more nervous on a hot August day. The next guy said, oh, I wish you was on page whatever, 50 or whatever it was. You solved this equation for us. Could you turn around and show us on the board the proof of that? Proof? I didn't know what they want for proof. What are you talking about proof? And I started getting really nervous. I said, I'm going to have to be here another semester. But I don't know these professors. I don't know who these guys were. They were asking me questions, but they had read my work. And the next one did something. And after an hour of that, was I drained? I was drained. I was drained. So they get up and just politely say, thank you, thank you, thank you. You'll receive a notice, in a couple of days. Oh. Whether you did okay, and move on. And wait 2 days. Did they give you an indication, did they even smile when they left? No. I thought, whoa. So I sat down at the table that's in the room, put my head down the table, I said, I did not make it. I'll probably have to be here another semester and try it again. That's what happens, you're not doing it correctly for them. You try it again, try it again, try it again. I thought, oh no. So they say, well, no, so 2 days, you wait 2 days, I was nervous those 2 days. I thought, oh, no, I already had a job, I was going to a job, I was going to work. I didn't want to stay in school another semester. I had a job waiting for me. I had to start making money. 2 days comes, I see this large envelope in my mailbox on campus. I said, oh, that must be it.